Yeah, this is a great question, and I think still a largely open question in as far as the engineering discipline is concerned. But what I'm excited about related to this question is this idea that we call beyond accuracy. Let me start by talking about traditional ML ops and traditional machine learning operations and building of machine learning models. The focus is usually on what we call model evaluation, right? So I've got a very precise, very specific task. Like, let's use the simple example of classifying cats or dogs in images. And I can measure accuracy of that task, right? So I have data that has cats and data that has dogs, and I run it through my model that I've trained, and I can measure the accuracy of that model. This is the large focus of the work that gets done in building of machine learning capabilities. A worry about this model evaluation concept and how well it does on the specific task. To get to the actual question and this idea of beyond accuracy, we're keenly interested in methods that, rather than looking at model evaluation and the precise, classification task, it's really important, and Rachel just said this, it's really important to think about the business or mission or operational context where the system, where this model will be deployed inside of a larger system. And that context can actually drive metrics. And those metrics are that balance between robustness and scalability and accuracy. In a really great example that I'll credit Marshall Hebert, the Dean of Computer Science at CMU with, there's a very common machine learning task called image segmentation. And so what image segmentation is given an image, how do I identify which pixels belong to which object in that image? So there might be a road and a car and a tree and a mountain in the background. Pixel by pixel in that image, can I classify what object that pixel is part of? And if you go into the academic literature and look at image segmentation papers, the metric they use is overall accuracy. And so how accurate am I on a pixel by pixel basis? Now, if you think about that, in most real world applications, this probably isn't required. It's probably not required to have every single pixel perfectly accurate. And so this is going beyond that accuracy measure and thinking about, can I trade off computational resources? Can I trade off robustness? Can I trade off accuracy to build the mission capability or the operational capability that I'm most interested in?
I can add one thing onto that, which is, I think this is where our work in AI engineering has a lot to learn from other engineering disciplines as well, because it's about how do you make smart design decisions and how do you track the impact of those decisions over time. Right now, a colleague of ours, Jay Palat, he likes to use Mary Shaw's definition of discipline growth and says that right now, a lot of AI is in the craft phase. We are trying things out. We're doing a lot of customization to get to that mission outcome, that business outcome, but we're not at the place of standardized, repeatable processes. A developer can run their program multiple times and get different answers. And it's a question of, well, why does that happen? And I think to get to that place where we are understanding what the trade-offs are and how to navigate them, it's going to take us as a discipline, some continued reflection around those intentions of what are we trying to do? Why are we trying to do it? What's the context in which we are making this trade-off? When does it make sense to prioritize one design consideration over another? And starting to share across those so there's lessons to be learned from the discipline. I think that's a focus of a lot of our work at the SEI is learning from others and trying to bring together those lessons learned and help people unpack the choices they made, whether implicitly or explicitly. And I think especially in this craft phase, a lot of times the choices we're making are more unconscious. We're just moving through or hacking it together to get it to work. And it's a matter of refining that process and thinking about what was my motivation there? Why did that technique work? Why did I make this decision? And getting clearer on that so then it can be shared and repeated by others in the future.